everyone, my name is Howen Shan for ECOSA conference title is Application of Mobile Game-Based Learning for Improving Operational Mathematics Knowledge Among Students. Researchers have increasingly viewed game-based learning as a viable strategy to enhance students' understanding of mathematical concepts, particularly the order of operation. This study aims to develop a mobile game-based learning framework to improve Year 4 students' skills in evaluating numerical expression and understanding the relationship between mathematical operations. We use a mixed method research design. We analyze pre- and post-test score and narrative feedback. The findings suggest that game-based learning significantly improves student mathematical skill and overall learning achievement. The study was conducted among upper primary students in rural schools in Tampin District, Negeri Sembilan. Background: digital games are becoming increasingly popular tools for education, offering new forms of creative expression and learning enhancement. Problem statement: despite their potential, the impact of digital game-based learning on young student mathematical skills, particularly operational mathematics, remain underexplored. Research objective: Number 1. Identify the elements of mobile game-based learning development for improving operational mathematics knowledge among students. Number 2. Develop a prototype of mobile game-based learning to improve operational mathematics knowledge among students. Number 3. Evaluate the effectiveness of the prototype. Research questions. Number 1. What are the elements of mobile game-based learning that are essential for improving operational mathematics knowledge among students? Number 2. How can a prototype of mobile game-based learning be developed to effectively enhance operational mathematics knowledge among students? Number 3. How effective is the developed prototype in improving operational mathematics knowledge among students? Literature review: Mathematics educations have evolved significantly over the years, with traditional methods being supplemented, sometimes replaced by digital approach. Each method had its strengths and challenges, and both play a crucial role in enhancing student understanding of mathematical concepts. The importance of arithmetic operations. Arithmetic operations like addition, subtraction, multiplication, and division are fundamental because they form the basis for most mathematical tasks. They help us solve everyday problems, understand complex concepts, and make decisions based on numerical data. Digital review examination was conducted of how digital games are used in education contexts. Conceptual model and framework are studied based on the review of existing models such as GRU, the CAR, Retain, and other relevant to game-based learning. Research framework is based on this analysis, design, development, implementation, and evaluation framework. Scope of research. The scope will concentrate on students' proficiency in executing the order operation when assessing numerical expression. The research involved 96 students with 10 participants meeting the initial requirements. The mobile game application will concentrate on teaching the process of performing operations on numbers, aligning the standard curriculum for primary school, textbook designed for Standard 4 students. The research aims to assess student acquisitions of operational mathematics knowledge in executing numerical operations. Literature survey conducted by Chang and Huang based on their study. to assess the effectiveness of mobile game-based learning approach in enhancing operational mathematics skill among elementary school students. The results demonstrate that this approach successfully improved learning achievement, attitudes, and fluency in operational mathematics. Additionally, students using the mobile game-based learning method shows higher level of engagement and motivation compared to those receiving traditional instruction, as reported in the study in 2019. Mathematical comprehension and effective communication have become a global concern. According to the Headlam and Graham in 2009, the order of operations principle is a fundamental building block for arithmetic understanding. Our research is to identification of the research gap. The research gap involves recognizing areas where existing study may have limitations or where there is a need for further investigation. In the context of developing a mobile application for learning the order of operation, consider the following. Technology accessibility. Inadequate investigation of technological accessibility, such as whether an application is device optimized or whether offline functions are taken into account to accommodate various technology contexts, may be a sign of research gap. This area is our focus. Research method. Our research design based on the mixed method approach, combining quantitative pre- and post-test with qualitative narrative analysis. Participants: upper primary students from rural school in Tampin District, Negeri Sembilan. Instrument: questionnaires, game interactions, logs, and observation notes. Data collection and analysis done by pre- and post-score comparison, user acceptance analysis, and usability tests based on the adapted design and implementation flow chart of mobile learning model. Research methodology. Start with analysis phase, preliminary study, literature review, understanding the rules, understanding the game design, evaluate the context needs, plan game design. Identify the characteristics, synthesis findings, survey users, identify gaps and opportunities. The findings and results. Unveiling the characteristics of game design based on the user opinions. Survey and interview. Analyze the findings, activities, analysis of mobile game characteristics. For design and development, software and tools. The development of the mobile games for enhancing operational mathematics knowledge among students involve a combination of software and tools designed to streamline the process of game design, programming, and testing. Below is a brief overview of the key software and tools used in the research. The software and the function. Game design documentation. The design and development of the mobile game-based learning platform were carefully crafted to integrate educational content streamly with engaging gameplay. This approach ensures the student not only enjoy playing the game but also effectively enhance their mathematical skill, specifically in understanding the order of operation. Below is the detailed description of the key design elements and how education principles were integrated into the game development. Game design documentation. Number 1. Level design. The game is structured into multiple levels, each representing a progressively challenging set of mathematical problems. These levels are designed to align with the learning objective, starting with the basic operation and gradually introducing more complex numerical expression. The progressive ensure that students build foundational skill before tackling advanced concepts. Scoring and feedback. A dynamic scoring system is employed to reward the correct answer and provide immediate feedback on the incorrect ones. Guided learning path. The game incorporates a guide learning path where students are introduced to concept through in-game tutorial and hints. Educational context integration, alignment with curriculum standards. Problem-solving challenge. The game features interactive problem-solving challenges that require students to apply their knowledge of the order of operation. These challenges are designed to mimic real-world mathematical problems, helping students understand the practical application of their learning. Game design, reinforcement through repetition, visual and interactive elements, user interface design. The UI is designed to be intuitive and visually appealing, with a focus on ease of navigation. Bright colors, engaging animation, and clear instruction are used to keep students motivated and reduce cognitive load, allowing them to focus on the learning content. Interactive element. The game incorporates drag and drop features, clickable options, and animated sequences that respond to user inputs. Motivational elements. Gamification techniques such as badge, leaderboard, and reward are integrated into the game to motivate students. Adaptive learning features. The game is designed with adaptive learning features that adjust the difficulty based on the student performance. If a student struggles with the particular concept, the game provides additional support and simpler problems to help them improve before moving on to more complex tasks. Let's have a glance on tutorial how to play mobile application SureMap. Finding and the result. Based on a user acceptance analysis, usability analysis, game design evaluation analysis. Data finding. The reliability analysis is overall alpha value is 0.91. For information 0.77, interface 0.87, interaction 0.85. Data finding. The individual construct information in interface and interaction all exhibit good to excellent reliability with the overall tool demonstrating excellent internal consistency. The overall Cronbach alpha value of 0.91 across all the constructs reflect the excellent internal consistency. This indicated that collectively the items in our research or survey measure tools are highly reliable, providing a consistent measure across the information, interface, and interaction construct. Based on the data from the table 5.1, the total number of respondents who answered the questionnaire is 96 students. This is the distribution of respondents by gender. There are 62 male, 34 female. Distribution respondent by race: 27 Malay, 63 Chinese, 6 Indian. On the table 5.2, regularity of playing computer games. There are 3 of them play the game every day. Occasionally play the game is 72. Play the game every week is 21. Data finding: most of the students, where 16 students in total, have described themselves as a gamer. Tables show distribution of users by their interest in several game genres. From action puzzle games, there are 11. Action RPG and strategy games, there are 4. Action puzzle strategies, there are 19. Action strategy and others, there are 8. Adventures action puzzles, there are 14. Adventures RPG puzzle, 6. Adventures RPG strategies, 4. RPGs puzzles and others, 9. And the last one, RPG puzzle strategy, there are 21. About the game design characteristic, the correct alpha value of 0.902 in 25 items of instrument with 96 respondents indicates a high level of internal consistency among the items. In our reliability analysis based on user feedback and interaction data, interpretation of the alpha value falls within the range of excellent reliability. The high reliability score suggests that our measurements tool of 25 items away or test is likely well constructed and effective in capturing consistent responses. Conclusion: the compact alpha value of 0.9 suggests that our 25 items of measurements tools is highly reliable for assessing user feedback and interaction data among the 96 respondents. Game design characteristics analysis based on our feedback of user and interaction data. The ratio of 0.7 related to the enjoyment construct have an acceptable level of internal consistency. This suggests that the items are sufficiently correlate and likely measure the enjoyment construct reasonably well. For user acceptance and usability, the data analysis for user acceptance based on the 6 construct used derived from the GameX of the acceptance instrument to evaluate the user acceptance on mobile game learning. The first instrument is enjoyment, and the mean and ST show that in the table. For the finding of absorption construct, the highest item is the fourth item, while the lowest item in this construct is the first item. Next, the table shows the display of mean and value for the construct of user creative thinking. For user creative thinking, all of the items were shown in the range of 4 and above, which is agreed. Item 1 has the highest mean value, which is 4.1. All the students have a positive attitude towards the usage of mobile games in their learning. Next, the table 5.8 exhibits the finding for the activation construct. For the activation construct, this analysis result will portray to what extent the student believe in their ability to do something. Items 1 and item 4 gain the mean value of 3 and above, which is 3.65 and 3.27 respectively. This result also shows that the students are relatively not agree with the item 2 and item 3 for this construct, as the mean value of 2.97 and 2.64 respectively. For user perception analysis on item absent of negative effect, the table of 5.9s are lower than 3.5, which presents that the students were not agreed. The item in this construct was asking about the student absence of negative effect about using mobile game learning. The highest mean value is 3.68 for item number 3, while the lowest mean value in this construct goes to the item number 2, which is 3.29. The analysis from Table 5.10 exhibits the mean value of dominance of the students toward the usage of mobile game learning. There are three items here in dotted, and all of the items show the students agree as the mean value was above 3.0. Item number 2 shows that the student relatively agreed with it was the mean value of 3.86. However, the mean value is not far from the mean value of 4.0. Here is the table of all the constructs have been analyzed, and the results show most of them have been agreed by the student where the mean value are closely to 4. Activation have the lowest value, which is 3.13. However, the mean value of enjoyment is 4.0, which means it can be said as relatively agreed by the students. The construct of absence of negative effect score mean value of 3.46. The developed prototype has been evaluated by the user using the user evaluation form for mobile game design implemented with mobile learning elements. There are 4 constructs has been used for this instrument: information design, interface design, interaction design, and technical and technology. Based on the finding, show that the most of the user agree that this mobile game learning have the characteristic need for the game design. As all the construct gain above 4.0 for the mean value, the highest mean value obtained by the information design construct, which is 4.39, while the lowest mean value obtained by the interface design construct with 4.17. Data triangulation. There are 3 processes to obtain the feedback from expert and user validation. First process involves 2 experts and 96 users. They provide the feedback on the game design questionnaire. Second process obtained from the fans and experts and user. The third process for game evaluation through playtest by 10 students evaluating their interface design and user acceptance. The strategy is using multiple scores and methods help to ensure that the mobile game application was validated. For the future scope, this study has contributed on several contributions, such as Education Institute, Mobile Game Design for Learning, Mobile Game Designer and Developer, and the game prototype. For the discussed question, our contribution of objective is the game design characteristic implement with mobile learning elements guideline for the game design, the instrument of the game design characteristic. For the second research question, our contribution of this research is the educational game prototype for primary students and the teachers. For the third research question, we answer that the conceptual framework suitable for the user acceptance on mobile education game integrated with mobile learning elements and the guideline. Despite the positive contribution in our research, it's essential to acknowledge there are certain limitations in the research and mobile application development. Considering the identified limitations, several recommendations for future study can be proposed for future advance the understanding of the mobile applications impact on the order of operation in mathematics educations. The research successfully meets its goal and is expected to advance mobile application in education. The study's mobile game prototype improved learning for primary 4 students in mathematics, particularly in the order of operations. Recommendation for the future research provide a roadmap for enhancing and innovating mobile game-based learning. By following this prototype and the guideline, the application can evolve, address limitations, and better serve diverse educational needs. Overall, the research aims to foster effective mobile-based learning in mathematics education through a systematic approach. Here is the gains of the appendix we have conducted for our respondents. Summary of conclusion. This research successfully improved learning through a mobile game prototype for primary 4 students in mathematics. It contributes to the field of research and development in mobile applications for education. Recommendations for future study and enhancements are provided. This goal is to leverage mobile applications effectively in educational settings. By adhering to this guideline in future developments, the mobile applications can contribute to involve addressing limitation and maximizing its impact on mathematics educations. These recommendations aim to guide the ongoing improvement and adaptation of the application to diverse educational settings and user needs. In summary, the research follows a systematic process from problem identification for user testing and documentation, with the ultimate goal of contribution to effective mobile-based game learning in mathematics education, specifically focusing on the order of operation.